Hey guys, welcome back to Home Built, and this week we are back on the Frankenhauler and we're going to finish up all of the sheet metal work in the engine bay. All right guys, welcome back, and those who've been following know that this is the Frankenhauler. This is my 1954 Ford F600 truck cab that I've put onto a Toyota Coaster bus chassis. If you missed last episode where I was working on the inner guards, I'll put a link up above so you can catch up, and like always, do the things, like and comment. All that stuff helps out that crazy algorithm. So where we left off on the truck, we were working on the inner guards, and I was doing some sheet metal in there and getting that all sort of fixed up. There were some really good comments about sealing up the last little bits of the wheel arches so that I don't get muck off the tyres into the engine bay, using some sheets of rubber, which I'll definitely do. That was very handy, and yeah, thank you very much for that. Now, I did mention that I actually had a meeting on the weekend with my engineer, just going over, double checking what I've done. He's very happy with everything I've done so far. Yeah, no notes on any of that. One thing that did come up, and we discussed it back and forwards a fair bit, my goal for this truck is to try and keep it on a car license in New South Wales. So, I think basically all car license in Australia, you can have a GVM, so gross vehicle max, up to 4.5 tonne maximum. So I need to have this rolling around at about 3 tonne at the most to be able to carry a 1.5 tonne, up to a 1.5 tonne car on the back. Now, I know that the chassis and the engine are very heavy, but from what I could gather, the bus, when it was standard, original, was about 3 tonne empty. So that had a GVM of 49.90 or something on that bus, because obviously it's a 22 passenger bus, so it's got to have 22 people in it. Now, I cut a lot of weight off. All of the glass off the bus, all of the steel of the roof and the seats, and all of that sort of stuff is a lot of weight that I have removed. So this should be quite light. As you've seen, I can lift the cab on. Granted, there's no glass and doors or anything else in it, but I can lift the cab around by myself quite easily. I guess it would weigh 60 kilos, 70 kilos. It can't be more than 100, because I wouldn't be able to lift it as easily as I do if it was that heavy. So it's quite light. The sheet metal work is relatively light. So the issue I was having is with the tray on the rear. The mechanism I was going to build, and if those of you haven't followed along, my plan was always on the back is to get the tray from the back of the truck to come all the way off the back of the truck and end up going flat or close to flat onto the ground behind, so I can get a low cut on easily, and then it would go back up onto the tray. The issues with that, there's lots of issues with that, but overall it's extremely complicated. I could definitely do it. It's going to take me a long time to do it, and I think I'm having a change of plan. So let me just run you through now what my original plan was. All right, so I've got a range of sketches here that I made up for the engineer. Now, if we start with this sketch, so you can see here that this is the tray that was going to be all the way sort of not quite flat off of the back, but very close to flat, and the full 4.5 meter long tray that I'm going to have on the back of the truck. Now, this was going to be attached by a hinge point here, and this would be a trolley with a couple of girder rollers, and this would be a track like a C channel, that these rollers could roll backwards and forwards on this track, and that trolley would be connected to a winch that would be able to pull it forwards and backwards. The winch would have two reels on it, so when it's spooled one way, it's going to pull it one way, and then when it's spooled the other way, the other reel would pull it back. So that would work with one winch. But basically what would happen is it would get pulled up onto the this frame. There'd be a roller under here so that it'd catch the back of the tray, and as it moved forward, it would reach a tipping point, and the framework that's pivoted here would fall and land onto the cab, and this would have a shock absorber on it to stop it from banging down. So from going from this state to this state, as the whole thing fell down, the shock absorber would take up the slack, and then it would continue reeling it in until it locked in forward, and I'd have to create locks and all this sort of stuff. Overall, the thing is that I'd need to have a very heavy duty frame here with the trolleys on it to be able to take the full weight, and then I've got to have a heavy duty ramp because this needs to be able to be freestanding here, so the actual tray itself would have to be heavy duty, and the whole thing was extremely complicated. Particularly getting the locks to work and making sure that the tray, when it comes all the way off, it didn't, as it coming off the back, it doesn't skew left or right. It needs to keep it square, and there was lots and lots of complicated issues with that. And the main idea was just to get the approach angle extremely low so that I can quite easily get a low car onto the back of the truck. So I've done a little bit of a mock-up here. It's hard to sort of see it, but you can sort of see the back of the truck. Basically, the center point is about here. That's the center point of the tray, is the center point of the axle. So we've got 2.25 meters of tray that way and 2.25 meters of tray that way to give me a 4.5 meter long tray. Now, the end of this piece of timber is actually going to be where the back of the tray will finish up. Now, I am planning on cutting off these chassis rails and shortening them to about here, just behind where the rear suspension mount goes. All of this is all superfluous. I probably will cut off and lower it down and actually have some frame lower. But essentially, my new plan is to scrap my super complicated winch only plan and just go with a basic tipper trailer. So after all my talk of no hydraulics, I'm going to put a hydraulic pump, and basically when the hydraulic pump lifts up the tray, the back of the tray, this will be about the pivot point here at about the 3 meter mark. The back of the tray will get quite close to the ground, and then I'm going to have about 3.2 meter ramps going off the back of that. So it'll be a very, very easy transition to get a low car all the way onto the back of the cab. So basically, I've kind of worked it out. I'll play around with the hinge lengths, but at the moment I'm thinking I'll have my hinges for the tray at about 3.5 meters. So 2/3 of the way back will be where my hinges are. There'll be 1/3 hangover at the back, and the front I'll have a hydraulic ram. Now it's relatively easy to get a 24 volt hydraulic ram system. The cost of the whole ram setup, I've had a look, I can get it for about $1,250. The winch alone would be about $800 to be able to do that. So, and everything else is just so much simpler. So I just have the pivot, and basically from my rough calculations, I can quite easily get the back of the tray down to about 350 to 400 mil to 350 mil off of the ground. That's with the truck currently at this height. And then have 3.2 meter ramps off of that. So 3.2 meters only coming up that. It's going to be a very gradual, easy transition. Now I might look at building the ramps, but I can buy ramps off the shelf. So I'll just weigh it up. I may just end up buying them by the time I buy the aluminium and spend all the time welding aluminium, which is not my favourite thing to weld anyway. It might be easy to just buy ramps that I can slide under the tray and just have them slide out, and it's done. I really am swaying towards that being by far and away the simplest option. So yeah, as much as I would love to do my other system, and I know I could do it, and it's just going to take so much work, so much effort, and why do I do this to myself? I don't need to. Keep it simple, stupid. There's less room for errors and the whole thing is better. So, all right, enough yapping. Let's get back into doing that sheet metal work.
So hopefully that all made sense, and let me know in the comments if you think I'm crazy or if I'm going the right way. Let me know your opinion. But here we go, we're straight back into it, and you can see I actually started welding onto the foam of the paint stand and caught it on fire, so I had to prop it up with some timber and kept going. And most of this is pretty straightforward now, as I did the hard yards last week, so it's just TIG welding the whole thing together and doing one continuous seam. And a quick trial fit before I grind everything down and make sure it's all nice and neat and tidy.
All right, I'm quite happy with this. I've gone around, I've welded up. There were lots of little holes around the place that I've welded up as well, and we have our whole inner structure all looking pretty good now. Besides coming back, and like I said, I'm going to add in some rubber sort of flaps in there to patch up any of the little openings so that I avoid most of the muck going in the engine bay. But let's put it back on the truck and see how it looks.
So a quick coat of etch primer just to stop any surface rust while I'm messing around, and then quickly line it all up. So I planned on attaching the power steering hose mount to the front of the guard, but I couldn't get under the power steering hoses without removing them to put in a captive nut. So I decided to just drill that out and bolt them solid and make a separate mount for the inner guard. So for the front guard, I want a captive nut. So you can see I'm using the step drill into the frame and then a flange nut so that it sits in, it doesn't fall through, and that is the perfect captive nut. Now all I have to do is go in and TIG weld around the edge, and I have the captive nut in place. Give it a coat of chassis black to hide it all in. Then I just need to trim out the front guard to match.
All right, so you saw me there. I drilled in and fitted a captive nut to bolt the guard to. Originally, I designed it so that the inner guard would bolt underneath the these power steering lines, and it would all be bolted together. But these power steering lines are in, and they're in position, and I don't want to move them. I'd have to unbolt them all to get under it to weld in a captive nut. So I just put a nut and bolt through here. This can stay connected, and if I ever want to remove the front, I just have to remove it from a separate bolt, and I cut out a step around it. So let's refit this guard, and it will be independent from the power steering lines.
So just double checking everything fits. Yep, beautiful. So now I can take it off and finish off the entire front end of this inner guard. So this is where the intercooler piping goes through, and I just want to make everything nice and neat and tidy and finished so that it is ready to paint.
All right, I am very happy. I have one side down. I've tidied up the front now where the intercooler pipes come through and around here. So that is all ready to go, ready to come off and get painted. So now it's time to just tidy up this side. Should be a bit easier because we don't have to worry about steering columns and stuff. I just need to make a panel to fill in here, something similar to the other side. So let's do that.
So it's back to the old school CAD, cardboard aided design, and I am drawing up my patch panel, and it's just a lot of cutting and trimming and backwards and forwards until I get the shape exactly the way I want it in the cardboard. And once I've trimmed that out and I'm happy with that, then it is time to transfer it over onto the sheet metal. I quickly trim it out with the bench shear and fold it roughly into shape and manipulate it until it fits nicely, and then use some Clecos to hold it in place.
All right, I'm very happy with that. That's the plate is in there. I've got a couple of folds. I've got a bunch of clecos around it, and there is some gaps around the back, but like we mentioned, I'm going to just use some rubber sheet in there to attach to that to seal it up a little bit better later. So now it's time to get it off, to get all this surface rust off and weld it up.
So remove the panel and then do the messy work of removing all of this surface rust. Again, I'm mostly using a flap disc for this. I'm pretty precise with the angle grinder these days, so I'm not really taking off any of the parent metal. I'm just knocking back all of the rust and then going over it again with a wire wheel. Doing the front end trim out like I did on the other side as well while I'm there, and then just double check, make sure everything is right, and then I scribe around the edge of the join. And what I'm doing here is I'm cutting back to my scribe line but leaving tabs where the clecos are joined. So this might look odd, but basically what this means is then I can cleco this back onto the panel, and in between the clecos I can get a perfect flat level butt weld, then remove the cleco, trim back the tab where it was, and eventually work my way around and get the entire panel perfectly flush. Now this is time consuming and it's a little tedious, but it's a very nice way to get it exactly where you want it. And as you can see here, I'm just working my way around, tacking as I go, and just getting every section perfectly neat and level, and trimmed off the tab from underneath. And as you can see now, upside down, the tabs are mostly trimmed off. And once I'm happy that the panels are nice and level, I can then go around and TIG weld in the whole thing in one big strip. And while I'm at it, I'm going through and just welding up all of the little holes that were in these inner guards that were holding on all sorts of things. There were a bunch of clips that were holding wires and things like that, which I can do my own versions later when I get to it. But a bit of a grind back and a little bit of panel beating to make sure everything's nice and flat and smooth, and I am pretty happy.
All right, I am very happy with that. We actually have the guards on both sides all finished up, so now it's time to get them back off the truck and get them ready for paint.
So I go around and I hit these again, as I've done with everything else, with the rust converter, and once they're done I come back with some bicarbonate of soda in some water just to neutralize the acid and wash it all off. Give them a thorough dry and then paint them in POR 15.
All right, well, it's the following morning. It was a little bit cold overnight, so it does sort of make the POR 15 go a little bit odd in the drying stage, but it's all quite good, all nice and hard. So I'm going to scuff it all up now and we'll get it ready to put some stone guard on.
So I've got the heater blasting into the booth and I'm going over everything with some Scotch-Brite before getting out the Schutz gun and hitting the inside of all of these guards with some stone guard. And it gives a very nice finish for in the wheel arches.
All right, so I've got the stone guard done on those pieces and I'm looking around and I think I have actually finished all of the rust repair on the cab and the front end of the truck. That we're sorted. That's a massive milestone. I am extremely excited right now. So I think the next thing I need to do is I need to move forward into getting the truck running like it is. And a few things that we do not have actually properly connected up yet is the brake and clutch pedals have no master cylinder and they have no fluid line. So let's start having a look at that.
So for the brake and clutch lines, I've got this bulkhead fitting off of the bus, which I'm just going to give a little quick scuff up and some cold gower paint just to make it a little bit prettier. Then I need to make a mount for it. I did cut a hole previously, but I never actually made a mount, so I'm just going to draw something up quickly on some cardboard, use the sheet metal to make up a little bracket, give it a coat of paint, and I can drill and bolt it onto the firewall. So there were brake and clutch lines coming out of the original master cylinders, but I wasn't happy with the clutch line, so I'm making a new one. So using the Raceworks flaring tool, the first operation just gets the new tube in the right location, and then I turn it around to make a bubble flare to start with. Bit of lubrication, and then this makes a nice bubble flare. Then the next operation, turning it around, will actually invert it and make it inverted flare. Don't make the mistake of just making a straight inverted flare and just flaring out the end, because it actually needs to be folded over double, and it makes a much better fitting. But don't forget to put the fittings on before you make it. In this case, I flared one end and then put both fittings on before flaring the other. And then it's a matter of bending it up to get it to fit into place. And here I am actually wrestling with the original brake lines. So the original brake lines were in reasonable condition, but I wanted to straighten them out using my roller. So it was a little bit of messing around to get them to fit into the roller and just straightening them all out, but I'm quite happy with the result, and I know that they are quality brake line material, because that's what was factory. And once I straightened out the original brake lines, I could then re-bend them and curve them into the location that I needed them up under the dash, which is a little bit of wrestling, but it gets a good result in the end. Okay, so I made a brand new line for the clutch. It was a bit more difficult to get it in around behind, so it was just easier to work with a brand new line. But I straightened out the old lines for the front and rear brakes and sort of ran them up, and they are now connected up. So we have the internal part of the brake lines and clutch lines all connected. So I plan on adding a couple of clips to mount and tidy up those brake lines. But moving on, I'm actually making a mount here for the reservoir and connecting that all up inside. All right, so I dropped my camera again, so I lost a whole bunch of footage. But what I've been doing for the last couple of hours is basically, this is the reservoir for the brake fluid. Now I had to get it as high as possible to be higher than the level of the master cylinders. The master cylinders actually sit quite high up here, so I had to have enough head height to be able to obviously get the fluid to the master cylinders. I drilled a few holes in the firewall and used some grommets and ran the hoses through there. And they come there under the dash, and they come through and are connected up to the master cylinders themselves. So we actually have that side of things all plumbed. So now we have everything from the reservoir all the way through the pedals and master cylinders. We just need to connect up the lines from here to connect to the existing lines to the brakes on the front and the rear and the clutch. So I'm happy with my brackets for the reservoir, so I just give them a quick coat of paint before mounting them up and calling that job done. And last thing is to drill a hole and mount some grommets through for the brake level sensor. All right, well, I have gone a long way forward in this episode. Getting the last of the welding done, getting the paint started on the inner guards. I've still got some more painting to do. I've got to do some body work on the inside of the doors and things like that, but that can sort of be done in the background. I'm really getting to the pointy end of getting this truck rolling under its own steam, and having brakes and clutch is a big way towards that. But as I said, I've still got to do the lines under the truck, the brake and clutch lines, so that's still to come. There is still some other plumbing I've got to do in the engine bay. I've got to add the vacuum lines to the brake booster, and a few bits and pieces that I still need to sort out. But we're at the quick bit. This is going to start moving quite fast now. So hopefully you enjoyed that. Hopefully you enjoyed my description of the back, and let me know if you think I should have kept on with the really complicated tray, or whether I should just go with the tilt. I am
Yeah, I'm really swaying towards the tilt now because I just think it is so much more practical for what I'm doing, lighter and easier and quicker, and we can just plow on through. So let me know. But I think we're out of time here, so I think that means it's time for Fun Facts with Mrs. Jeff.
Hey guys, today we have a special behind the scenes fun facts, as one of our fabulous patrons reached out with some insider knowledge. Our patron John Mullins happens to be the plant manager at the Ford, Ohio assembly plant, which happens to build Ford's heavy trucks. His facility employs 1,300 production employees who are supported by 400 engineers. The plant produces 400 trucks a day at around 50 per hour. These consist of the F350 and 450 Super Duty chassis cabs and the F650 and 750 medium truck chassis cabs. They produce over 10,000 unique vehicle configurations and 330 frame variations. In addition, there are 15 engine variations and even over 400 different F650, 750 drive shafts. The factory was first built in 1946 and has recently doubled in size to over 700,000 square meters. Once completely assembled, each truck goes on a battery of tests, including being run on rollers, a water soaking, and of course a final quality inspection before being driven on a 25-mile drive to check for any noises or vibrations. As John said, many people think these are commercial vehicles which will become garbage trucks or dump trucks, and no one cares about a speck of dust in the paint. He cares, Ford cares, and his team cares.
All right, we have finished all of the rust repairs on the cab. I'm very surprised. There may be little tiny bits and pieces in the future, but basically all of the panels are ready to go now, which is amazing. So it is now the assembly time. It's the final bits of paint, and we can actually hopefully get this cab running and moving under its own steam very soon. So it means I have to I've got some logistics I've got to work out in the background, things I've got to order, and things are going to start moving quick. So yeah.
That's great. That's often not the case, is it? It's usually a lot slower than you think it might be.
No, well, the bodywork stage is really slow, and I mean, there's still like the external painting, and there's bits and pieces to do. There's still plenty to go, but
the end is in sight.
Yeah, like we're really getting a lot closer, and yeah, it'd be a massive step forward when the truck can actually move under its own steam, and I can actually just start it up and drive it around. It will actually move by itself, which is going to be amazing.
It'll be amazing. So cool. As always, just subscribe if you haven't, and like the videos, and Patreon. Videos day early, no ads.
Yes, be a legend like John Mullins, and and help us. Yes, thanks. And hopefully you enjoy us on the next one. See you guys.
Happens to be the plant manager at the Ford, Ohio assembly plant. Happens to be the plant manager at Ford, Ohio assembly plants. Happens to be the plant manager at Ford, Ohio assembly plants. No. God. Our patron John Mullins happens to be the plant manager at the Ford. No. Our patron John Mullins happens to be the Ford, Ohio plant manager. Oh my God. Now these consist of the F360 and What?
350.
Oh. These consist of the F330 and 450. Whew, it's been a long day.